What you're about to see will rewrite everything we thought we knew about visitors from beyond our solar system. The James Webb Space Telescope has just achieved what many astronomers thought impossible, capturing the first crystal-clear, detailed image of Atlas, only the third interstellar object ever detected passing through our cosmic neighborhood. But here's what's shocking. This isn't just another space rock drifting through the void. Webb's infrared vision has revealed something extraordinary, a mysterious hybrid object that's part comet, part asteroid, actively releasing exotic molecules that don't belong in our solar system. And the most mind-bending part? It's carrying potential building blocks of life from another star system, supporting theories that life itself might spread across the galaxy through these cosmic wanderers. The James Webb Space Telescope has once again redefined what we thought was possible in astronomy. For decades, scientists dreamed of capturing a clear, high-resolution image of an interstellar object, an object not born in our solar system, but one that traveled across the vast reaches of space, carrying secrets of another star. Now, with the first-ever detailed image of 3I Atlas, that dream has become a reality. This isn't just another picture. It is a moment that will stand in history alongside humanity's greatest achievements in exploration. When Galileo first turned his telescope to the night sky, he discovered moons orbiting Jupiter and changed our understanding of the universe. When Hubble launched in the 1990s, it revealed galaxies beyond counting and reshaped our cosmic perspective. And now, James Webb has joined those ranks by giving us the clearest look yet at an interstellar traveler, an alien visitor that does not belong to our solar family. 3I Atlas is no ordinary object. It is only the third confirmed interstellar visitor we have ever detected. Before it, there was the strange, elongated Oumuamua in 2017, which left astronomers puzzled with its cigar-like shape and mysterious acceleration. Then came Borisov in 2019, a comet-like body venting gas as it shot through the solar system. Both of these objects were glimpses of something extraordinary, but they were fleeting, and the technology at the time limited what we could see. This time, however, is different. James Webb's power is unlike anything humanity has ever had at its disposal. Orbiting 1,000,000 miles away from Earth, shielded from the warmth of the sun, Webb stares into the cold depths of space with unmatched clarity. Its infrared eyes cut through cosmic dust and reveal details invisible to even the mighty Hubble. When scientists turned this instrument toward 3I Atlas, what came back was more than data. It was a window into another star system's history. Imagine this: a body born around another sun, forged from dust and ice billions of years ago, violently ejected by the gravity of giant planets, and left to wander the galaxy for untold ages. Now, by a twist of cosmic fate, it passes through our own neighborhood, and humanity, at just the right time, has the technology to witness it. This alignment of chance, technology, and timing is nothing short of miraculous. The image itself is a revelation. For the first time, we are not staring at a distant blur or a faint point of light, but at a resolved body, clear, sharp, undeniable. This single achievement opens doors to new science, new debates, and new possibilities. For astronomers, it is a milestone. For humanity, it is a reminder. We are not isolated in the universe. Matter from other stars flows into our system, touches our world, and then moves on into the darkness. With 3I Atlas, the James Webb Space Telescope has given us more than a photograph. It has given us evidence that the cosmos is alive with motion, exchange, and mystery, and it has placed us, for a brief moment, face to face with an alien traveler that will never return. When Oumuamua first appeared in 2017, it was unlike anything we had ever seen. A strange, elongated object tumbling end over end, too faint and too fast to study in detail. All we had were blurry telescope images, points of light on a graph, and theories that spiraled into science fiction. Was it a rock? Was it a comet? Was it even, as some dared to suggest, a fragment of alien technology? The truth is, we never got close enough to know. Oumuamua slipped away before our instruments could truly focus on it. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. 2 years later, in 2019, another interstellar visitor entered our solar system, 2I Borisov. This time, we were ready with better instruments. But even then, our view was limited. We saw a glowing tail, a classic comet-like body releasing gas and dust, but it was still a fleeting blur in the darkness. Once again, we were left with more questions than answers. But Atlas, this is different. With James Webb, the image we now have is sharper, clearer, and more detailed than anything captured before of an interstellar traveler. Webb does not just see light, it sees the invisible. Its infrared instruments allow it to pierce through dust, track heat signatures, and separate chemical fingerprints. And when it turned its gaze to Atlas, the results were breathtaking. For the first time, we can see the body of an interstellar object in stunning clarity. The image shows a dark, fractured surface, scarred with age, broken in places by bright icy regions that shimmer in Webb's detectors. These are not just random patterns, they are clues written into the body of Atlas about how it formed, how it traveled, and how it is slowly breaking down as it enters our solar system's warmth. But Webb revealed more than just the surface. Surrounding Atlas is a faint but undeniable halo, a coma, the telltale sign of gas and dust streaming away. This is proof that Atlas is active, releasing material into space as sunlight heats its ices. With Webb's precision, astronomers were able to separate the glow of the coma from the solid body itself, a feat never before achieved with an interstellar visitor. The difference in clarity cannot be overstated. Where Oumuamua and Borisov left us with mysteries, Atlas leaves us with revelations. Instead of a distant blur, we see a world in detail. Instead of speculation, we have data. For the first time, astronomers can measure its size with confidence, analyze its composition directly, and map out its structure. Think about what this means. An object born in another star system carrying the chemical fingerprints of its creation, now revealed with a precision that even a decade ago would have been unthinkable. Every pixel of Webb's image is a message from a distant world, written in light that has traveled across space and now rests in human hands. Atlas is not just sharper than ever before. It is a turning point. This is no longer guesswork, no longer faint traces and missed chances. For the first time in human history, we are seeing an alien object from beyond our solar system with clarity, with certainty, and with a level of detail that makes it real, tangible, and unforgettable. When astronomers first studied the Webb images of 3I Atlas, one feature stood out immediately. This is no ordinary comet and no ordinary asteroid. In fact, it seems to be both at once, a strange hybrid of rock and ice, forged in a distant star system, now carrying the scars of its violent past across interstellar space. The reflective icy patches scattered across its surface shine brightly in Webb's infrared view. These regions are actively sublimating, turning directly from ice into gas as the sun's heat strikes them. Streams of material escape into space, feeding the thin halo that surrounds Atlas. This is what gives it a comet-like nature, a body, alive with activity, bleeding gases and dust into the void. But then, there is the other side of Atlas. Surrounding those shimmering icy veins are vast, dark scars, rocky regions battered by ancient collisions. These are not smooth surfaces. They are fractured, cratered, and scarred by impacts, just as the asteroids in our solar system are. Some of these marks appear to be billions of years old, carved long before Atlas was ejected from its home star system. This duality is fascinating. In our solar system, we draw a clear line between comets and asteroids. Comets are icy, fragile, with bright tails and outgassing activity. Asteroids are rocky, solid, and largely inert, orbiting quietly in belts or near planets. But Atlas refuses to fit into either category. It is both comet and asteroid, an interstellar chimera that challenges the way we classify small bodies. What does this mean? To scientists, it suggests that planetary systems beyond our own may produce bodies with a wider variety of compositions than we expected. Perhaps in other systems, the boundary between icy comets and rocky asteroids is not as strict. Perhaps entire families of hybrid objects roam the galaxy, waiting to cross paths with other stars. The rocky scars also tell another story. They suggest Atlas has lived through violent times. Impacts scarred its body before it was thrown out into interstellar space. Every fracture and every crater carries the memory of ancient collisions, the kind that shaped planets and moons in the earliest days of solar systems. To study Atlas is to study not just its present form, but the chaotic history of a distant star system. Then there is the mystery of its strength. Unlike a fragile comet that could break apart under the stresses of interstellar travel, Atlas has survived. It has endured countless years of drifting between the stars, battered by cosmic rays, frozen to its core, and yet it remains intact. This resilience hints at a robust internal structure, stronger than we expected from a typical comet, yet not as solid as a pure asteroid. It is this hybrid nature that excites astronomers most. For the first time, we are holding evidence that the small worlds of other star systems may not fit neatly into our definitions. Atlas is rewriting the categories we use to understand space. It is telling us that the universe is more complex, more creative, and more unpredictable than we imagined. Looking at its icy glow and battered scars, one thing becomes clear. Atlas is a survivor, a relic of another sun's creation, carrying, within its surface, the blueprint of a world we cannot see. And thanks to James Webb, humanity now has the chance to read those blueprints for the very first time. Surrounding Atlas is a glow that cannot be ignored. When the James Webb Space Telescope turned its eyes to this interstellar traveler, it revealed more than just a rocky body with icy scars. It revealed a living halo, an active coma of gas and dust streaming into space. This is the unmistakable signature of a body that is shedding its ancient material, exposing what has remained hidden since the dawn of its creation. For astronomers, this is nothing short of extraordinary. You see, most objects drifting between the stars are thought to be cold, silent, and inert, frozen relics of their parent systems, locked away from light and warmth. But Atlas is different. As it entered our solar system and felt the heat of our sun for the very first time, its surface responded. Ices buried beneath dark layers began to vaporize, releasing jets of gas and dust into space. This outgassing created a faint but undeniable halo, the coma, that Webb captured in astonishing detail. But this coma is not just beautiful. It is a treasure trove of science. Every molecule that escapes carries with it the chemical memory of Atlas's birthplace. These are volatile compounds that have been preserved, untouched, for billions of years. By analyzing the coma, astronomers are essentially sampling pristine interstellar material without ever leaving Earth. It is as if Atlas itself is offering us a piece of its origin, carried across the galaxy, waiting to be read like a message from another star. And Webb's instruments are perfectly suited for this task. Its spectrographs can separate light into its individual wavelengths, revealing the fingerprints of different elements and compounds. When Webb observed the coma of Atlas, it found water vapor, clear evidence of icy reservoirs deep within the breather body. But it also detected something more exotic: carbon-rich organics, molecules that are rare in our solar system but could be common in others. These organics are the kind of building blocks scientists believe may play a role in the origins of life. Imagine that, for a moment. A fragment of another solar system, billions of years old, now shedding material into the space around it. That material drifts outward, and with Webb, we are able to capture its light, decode its chemistry, and uncover the secrets of a place we can never visit. It is like reaching across the gulf of stars and holding in our hands the ancient recipe for a world that formed light years away. The Coma also tells us something about the fragility and endurance of Atlas. Each jet of gas weakens the body, slowly eroding it as it races past our sun. But the fact that it still holds so much volatile material after countless eons in interstellar space shows how well protected its core must be. Beneath layers of rock and dust, the ices were preserved, waiting for this moment, waiting to be released under the light of a foreign star. This is why astronomers are so captivated by Atlas. It is not only the third interstellar object we have ever seen. It is the first to reveal its secrets in this way, through its active coma. Oumuamua never displayed such activity. Borisov showed hints of it, but not with this level of clarity. Atlas is the first true window into the chemistry of another star system. What we are witnessing is more than just gas and dust escaping into space. We are watching history itself unravel, frozen material from a time before planets formed, before stars like our sun fully ignited. Each molecule escaping from Atlas is older than our world, older than Earth, and perhaps older than life itself. And now, for the very first time, we are able to study it. Atlas's coma is not just a halo, it is a revelation, a glowing, ghostly reminder that the galaxy is alive with travelers carrying with them the secrets of their birth. And thanks to James Webb, humanity is finally able to listen to what those travelers have to say. If the coma of Atlas is the messenger, then the message it carries is written in chemistry. And thanks to the unmatched sensitivity of the James Webb Space Telescope, we now have the ability to read that message in extraordinary detail. When Webb's spectrographs focused on the gases escaping from Atlas, they did what no other telescope could: split the light into its elemental fingerprints. Every peak, every line in the spectrum corresponded to a different molecule. And what they revealed has left astronomers both stunned and inspired. First, there was water, pure, unmistakable. Water ice sublimating into vapor. This discovery confirmed what scientists had hoped. Beneath the battered rocky exterior, Atlas holds reservoirs of ancient ice, preserved since its formation in another solar system. But water alone was only the beginning. Webb also detected organic molecules, carbon-based compounds that are the building blocks of biology. And here is where things become extraordinary. These were not just the simple organics we often see on comets within our own solar system. Many of the detected compounds are exotic, rare, and in some cases, entirely unfamiliar to us. Their spectral signatures suggest complex chemistries that we do not typically find on comets and asteroids orbiting the Sun. This means that Atlas carries with it a chemical fingerprint of its birthplace, one that is different from our own. The molecules escaping into its coma were forged under the light of another star, in a molecular cloud with conditions unlike anything we know here. They are fragments of alien chemistry, preserved for billions of years, and now drifting through our solar system for the first time. To astrobiologists, this is electrifying. For decades, scientists have debated the idea of panspermia, the theory that the seeds of life might spread across the galaxy, carried on interstellar objects like comets and asteroids. If bodies like Atlas can transport water and complex organics from star system to star system, then the possibility that life's building blocks are distributed on a cosmic scale becomes far more plausible. Imagine it. Long ago, when Atlas was still bound to its home star, collisions and gravitational chaos ejected it into the void. For eons, it traveled silently between the stars, carrying within it the very molecules that could, under the right conditions, give rise to biology. Now, as it passes through our solar system, those molecules are released, glowing faintly in its coma, and Webb has captured them for us to study. This is not just chemistry. It is a direct link between worlds. It tells us that our solar system is not unique in producing water, ices, and organics. The processes that made Earth habitable may be repeated throughout the galaxy. And if these building blocks are common, then perhaps life itself is not rare, but widespread, waiting only for the right conditions to emerge. The fingerprint of Atlas also gives us a new tool for understanding planetary formation. By comparing its chemistry with that of comets from our own system, astronomers can begin to see the differences between star systems. It is as though each interstellar visitor is a sample return mission, bringing us material from another world, without the need for spacecraft. But more than that, there is something deeply humbling in this discovery. When we look at the spectrum of Atlas, we are not just analyzing molecules, we are peering into the origins of life itself, and perhaps even the origins of our own story. It forces us to ask, did life on Earth begin with material like this? Were the seeds of biology carried here on comets billions of years ago, just as Atlas now carries them across the galaxy? The chemical fingerprint of Atlas is more than science. It is a cosmic signature, etched in light, whispering that the universe may be full of potential for life. And with Webb, humanity has finally learned how to read that whisper. The more Webb studied Atlas, the more it became clear. This was not just another fleeting visitor like Oumuamua or Borisov. Atlas is a survivor, a colossal traveler that has endured the most violent forces of the cosmos and emerged intact. Measurements revealed its true scale, several kilometers across. To put that in perspective, Atlas is many times larger than Oumuamua and significantly more massive than Borisov. This makes it a true heavyweight among the rare class of interstellar objects we have ever witnessed. Its size alone tells us something remarkable. Atlas has survived a journey that should have destroyed it. Think of what that journey must have been. Long ago, in another star system, Atlas was born. It may have formed in the frozen outskirts, orbiting quietly with countless other icy bodies. But then came chaos. Perhaps a giant planet shifted its orbit. Perhaps two stars in a binary system tugged violently at each other. In that cosmic upheaval, Atlas was hurled out, torn from its sun, and flung into the interstellar void at unimaginable speed. Most objects that suffer such a fate are shattered, ground down to fragments, or stripped of their volatiles by the harsh radiation of deep space. Yet, Atlas survived. Its rocky shell, layered with ancient ices, protected its core for millions, perhaps billions of years as it drifted silently between the stars. Every impact scar on its surface, every fracture, is a testament to its resilience. And still, its interior remained untouched, preserving chemistry that is older than Earth itself. When compared with Oumuamua, the contrast is striking. Oumuamua was small, elongated, and puzzling, barely holding together as it tumbled through the solar system, vanishing before we could truly understand it. Borisov, though larger, disintegrated quickly, shedding material as it neared the sun. But Atlas is different. Its size and density mean it is far more stable, able to endure the stress of close passes and still hold on to much of its ancient material. This resilience has huge implications. It means that interstellar travelers like Atlas are not rare fragile shards, but robust messengers capable of carrying chemistry across the galaxy intact. These massive bodies can survive for billions of years, wandering from one star system to another, waiting to be caught by the gaze of telescopes like Webb. And there is something awe-inspiring in imagining the distances Atlas has crossed. It may have been traveling for hundreds of millions of years, surviving the radiation of empty space, the gravitational tides of passing stars, and the occasional collisions with micrometeorites. Yet, here it is, whole, active, and revealing its secrets to us. Atlas is more than just an interstellar visitor. It is proof that the galaxy is filled with survivors, ancient bodies that can endure chaos and destruction, carrying with them the frozen memory of their origins. Its scale is not just about size, it is about endurance, legacy, and the quiet persistence of matter as it journeys across the stars. By studying Atlas, scientists now understand that interstellar visitors are not always fragile. They can be massive, resilient, and capable of preserving their chemistry for eons. And that makes every future detection all the more exciting, because each one might be another colossal survivor, carrying secrets from a distant world into our own. Atlas is a reminder. The galaxy is not empty. It is alive with travelers, some fragile, some enduring. And this one, vast, scarred, but unbroken, has finally shared its story with us. If there is one thing the universe constantly reminds us of, it is that beauty is fleeting, and Atlas is no exception. Webb's precise measurements of its motion confirmed what astronomers suspected. Atlas is not bound to our sun. Its orbit is hyperbolic, an open curve that will never loop back. This means Atlas will make a single pass through our solar system before vanishing into the abyss of interstellar space forever. For astronomers, that realization carries both excitement and urgency. Every hour, every observation becomes precious. We will never get a second chance. Unlike comets that circle back after decades or centuries, Atlas will not return. It is a one-time visitor, a cosmic messenger whose path brings it near us for only a brief moment in its endless journey. The math behind its trajectory paints a dramatic picture. Atlas came hurtling toward us from the direction of distant constellations, carrying with it the invisible signature of its origin. It has been traveling for millions of years, untouched by any star, before being caught, just briefly, by the sun's gravitational influence. And soon, once it swings past and gains momentum, it will be gone, flung back into the infinite night between stars. There is something bittersweet about this. The Webb Telescope is capturing the most detailed look humanity will ever have of Atlas. Future generations will not see it again. Once it departs, only our images, data, and memories will remain. It is like watching a rare comet streak across the sky, except this one comes from another world, and it will never return. But its fleeting nature is precisely what makes these observations so valuable. Atlas is not just a curiosity, it is a sample of another planetary system delivered directly to us. Its chemistry, its structure, its orbit, all of it offers clues about the processes that shaped worlds far beyond our own. This is cosmic archaeology, with no do-overs. And perhaps that is why astronomers feel such urgency. The Webb Telescope is racing against time, recording every photon of light before the visitor fades. Because soon, Atlas will slip away, back into the silence of interstellar space, where it may drift for another billion years before ever encountering another star. Atlas is a reminder of how temporary these encounters are, and how extraordinary it is that we were here, now, with the tools to capture it. A chance alignment of time, technology, and curiosity allowed us to see it before it was gone. In that sense, Atlas is more than a discovery. It is a gift, a fleeting cosmic encounter we will never experience again. The discovery of Atlas is not just a momentary spectacle. It is a paradigm shift. Its observation forces scientists to rethink what we know about planetary formation, the distribution of life's building blocks, and the chemistry of the galaxy itself. First, Atlas challenges our models of planetary formation. Traditional theories assume that small bodies like asteroids and comets are largely confined to their home systems, forming in predictable zones around stars. Yet here is Atlas, a kilometer-scale object, ejected from another system, surviving for eons and now passing through ours intact. Its very existence confirms that planetary systems are not closed bubbles. They can shed debris into interstellar space, and some of that debris is robust enough to traverse light years without disintegrating. That reshapes our understanding of how matter moves and mixes between stars, suggesting that the galaxy is far more interconnected than we once imagined. Next comes the profound implications for astrobiology. Atlas carries water, ices, and complex organic molecules, ingredients that could seed life under the right conditions. This gives new weight to the panspermia hypothesis, which proposes that life, or at least its essential building blocks, can travel between star systems. While the concept has been debated for decades, Webb's observations provide tangible evidence that interstellar objects can preserve and transport these critical materials across vast distances. In essence, Atlas may be part of a galaxy-wide delivery system for the components of life. Then, there is the impact on cosmochemistry, the study of the chemical makeup of the universe. Until now, scientists relied mostly on objects from our own solar system to understand how elements and molecules are distributed in space. Atlas changes that. Its rare chemical composition offers a glimpse of a star system entirely different from our own. By analyzing its water, organic compounds, and other volatiles, astronomers can directly compare its chemistry to that of comets, asteroids, and planets in the solar system. This provides a kind of interstellar laboratory, helping us understand which processes are universal and which are unique to specific stellar environments. Beyond the raw data, Atlas also expands our theoretical imagination. If such objects are common, then the galaxy may be filled with travelers like this, each carrying a story of formation, evolution, and survival. Each one is a messenger from distant worlds, offering insights into the diversity of planetary systems and the potential pathways for life. The presence of Atlas suggests that the interstellar medium is not just empty space. It is a conveyor belt of material, chemistry, and information flowing between stars. Finally, the discovery compels scientists to look forward. Webb has shown what is possible with precise observation and advanced infrared technology. It sets a new standard for studying interstellar objects, encouraging future missions, instruments, and telescopes to focus on these rare visitors. Each new discovery will refine our models, test our hypotheses, and deepen our understanding of the universe on a galactic scale. Atlas is more than an object. It is a catalyst. Its passage is a call to science, reminding us that the cosmos is not static, but dynamic and interconnected. Through its study, we learn not just about a single interstellar traveler, but about the workings of galaxies, the origins of life, and the universality of chemistry across the stars. In short, Atlas reshapes our understanding of the universe in ways that will echo for decades to come. Atlas is more than a scientific marvel. Its journey through our solar system captures the imagination in ways that reach far beyond laboratories and telescopes. To the public, its image is both a window into the cosmos and a mirror reflecting our place within it. Consider the symbolism. Atlas is a traveler, moving across vast, empty space with no home in sight. It reminds us of migration, of journeys that are long, perilous, and transformative. Just as Atlas drifts between star systems, humans too navigate the uncertainties of life, constantly moving, exploring, and seeking connection. Its passage evokes a sense of impermanence, an understanding that nothing remains forever, and that moments of beauty are precious precisely because they are fleeting. At the same time, Atlas serves as a tangible connection to the galaxy beyond our solar system. Its composition, born in a distant star system billions of years ago, now touches our instruments, our eyes, and our imagination. In that sense, humanity is literally interacting with matter that has traveled across the stars. This interstellar link transforms abstract science into a deeply personal experience, reminding us that we are part of a vast, interconnected universe. Artists, writers, and storytellers have already begun to draw inspiration from Atlas. Its image sparks wonder, questions, and reflection on life, on our origins, and on the cosmic forces that shape all existence. Children looking at its picture may dream of becoming astronauts or scientists. Adults may pause to contemplate the fleeting nature of life and the enduring resilience of matter across time and space. Culturally, Atlas becomes a symbol of perspective. It encourages us to look up, to think beyond our planet, and to imagine the millions of worlds that exist unseen, carrying their own histories, chemistry, and stories. Philosophically, it challenges us to consider our own transience, the legacy we leave behind, and the possibility that life, or at least its building blocks, may be more common in the universe than we ever realized. In short, Atlas is not just an object in space. It is a bridge between science and human imagination, between data and meaning. Its fleeting visit reminds us of the fragility and wonder of existence and inspires us to reach further, think deeper, and embrace the awe of the cosmos. The passage of Atlas through our solar system marks the dawn of a new era in astronomy. Webb's unprecedented success has shown that interstellar objects are not just fleeting curiosities. They are messengers, each carrying vital information about worlds beyond our own. This realization is already reshaping how scientists plan. For the future, astronomers are now motivated to detect these visitors faster and earlier, developing more sophisticated surveys and telescopes capable of spotting small, distant objects before they make their closest approach. Time is of the essence. These objects pass through our solar system quickly, and each second of observation provides unique data that can never be repeated. But detection is only the first step. Webb has inspired a new vision for exploration: robotic missions designed to rendezvous with interstellar objects, sample their surfaces, and even return material to Earth. Imagine spacecraft meeting an alien comet or asteroid in the depths of space, unlocking chemical signatures that reveal the history of other star systems. The technological challenges are immense, but the potential payoff is extraordinary. Direct study of material that predates our own sun and planets. Beyond immediate missions, Atlas has ignited a broader shift in our understanding of the galaxy. Scientists now realize that interstellar debris could be abundant, forming a hidden network of material traveling between stars. This opens up the possibility of systematically studying these objects to learn about the diversity of planetary systems, the distribution of water and organics, and even the processes that could spread life across the cosmos. The legacy of Atlas is therefore twofold: scientific and aspirational. It provides concrete data that enriches cosmochemistry, astrobiology, and planetary science. But it also fuels imagination, encouraging humanity to look outward, to consider our place in a galaxy teeming with travelers. Webb's achievement is a clarion call to the next generation of astronomers and engineers. The cosmos is accessible if we are bold enough to reach for it. Ultimately, Atlas represents a turning point. Its brief visit has reshaped strategies, inspired missions, and confirmed that the universe holds far more interstellar travelers than previously imagined. With Webb lighting the way, humanity is no longer just a passive observer. We are poised to engage directly with alien material, to chart its journey, and to learn from its secrets, ushering in a new era of discovery where the boundaries of our solar system are no longer limits, but gateways. As Atlas disappears into the depths of space, it leaves behind a legacy of discovery and wonder. A messenger from another star system, it reminds us of the vastness of the cosmos and humanity's endless curiosity. Its fleeting visit may be over, but the inspiration it brings will last forever. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.